Okay, my name is Didier Barradas. I am part of the KAUST Visualization Lab. If you don't know, we have the KAUST Supercomputing Lab and we have the KAUST Visualization Lab, but both work in data science. Now, today I will try to give you hints about how to use Python for data science. To be honest, in 2 hours, you cannot become a master on Python, but give it 3 months and then you probably will be dangerous. Right now, I'm going just to give you what you will know, and you will leave here with more questions than answers, probably. But everything, I hope, will be clear. And I will give you basically the hints to do data science or wrangling files with Python. So this is the last of the workshop series that we do basically annually, which is the Data Visualization Core Lab workshop for data science. All right, so let's start. What is Python? Python is a high-level interpreter language. Interpreter is different than compilers. In computational science lingo, these are the slow versions of, for example, C++ and everything. However, Python is super flexible. It's multi-purpose. I mean, when I say flexible, think about it. Why does people is doing AI and machine learning in Python? It's because it's very flexible and has a lot of community behind it. I mean, sorry, guys, but you didn't crack AlphaFold, right? The AI community is towards Python because it's just easier, simpler. Is it the fastest? No. Is it the ultimate solution? Also no. But it's a very good tool. That's what it matters. You can do websites like Netflix. You can do, of course, machine learning, and you can develop also different tools for the community that you like. Well, it was created by some guy named Guido van Rossum, and the names derive from this British sketch comedy called Monty Python's Flying Circus. Now, I know about some of these movies. They're very British. So if you want to just relax a little bit, you can put one of these sketches. It's British, so you can probably enjoy it. Anyway, so why Python, right? Why would I learn Python? Because Python is now in every description possible of jobs for data science. You have different ways, different resources to learn it. I mean, you just have to look for it in YouTube. You will have thousands of different videos that will tell you, I can teach you Python, which is true. Many can do pretty much a better job than I will do today because they have like infinite numbers of hours. But okay, so it's highly integrated with anything. Pretty much even now, Windows has Python by default. And it has a very powerful family of GUIs, or graphic user interface, like PyCharm, VS Code, Eclipse, and the list goes on. You can install packages very quickly. For those of you that were here in the Conda workshop, you know this. You can just create some isolated environment and put whatever you want in there, and then you don't break things inside. Or you can go very easily with pip install, and boom, you have whatever you need. So it has pretty much packages that are for all tastes. Pandas, NumPy, stats model is for statistics, data wrangling, and basically scientific computing. NumPy is the most important one in this list, but also is very cryptic. However, Pandas, for example, is kind of easy, and it has his brothers, which is Rapids. From Rapids, you can basically input your data into a GPU. And Dask is basically the big brother because it just distributes your data into many GPUs or CPUs, depending on your taste. Okay. These lessons will be inspired by the material provided by the Carpentries. This is a nonprofit organization that wants you to become a a computer science connoisseur. It has plethora of courses about the core skills that you need to become a software developer or a data scientist, and so on and so forth. This is freely available, is out there for you. You will have the links. You already have the links and you can check it and do the exercise in your own time whenever you want. Even for a reference, they're very good. Now, today we're going to use something that is called the Jupyter Notebook. This is the most important tool for a data scientist as right now. Why? Because it's easy to deploy. You can write in many languages like Julia, R, Python, you name it. It's made basically with the purpose of sharing and educating people. So these notebooks actually end up in IPYNV because this project started with something called interactive Python, which basically was colorful Python, and notebook NV. Usually Python scripts are just .py and that's it. But these ones are special, and you will see why. Okay, so please start your terminals. For those of you that were here last time, you know that I like to use VS Code. If you have VS Code, that's the best right now. If you don't, you already had the setup sent to you. You probably have already Anaconda installed there, and you can deploy a Jupyter Lab and a Jupyter Notebook for sure. If everything fails, I also prepare a binder hub, which basically you have to go to GitHub into KAUST Lab KBL binder serve and push that button that says binder. It will launch a Jupyter Lab that will have Python installed for what we need. Okay. And if you're super brave, you can only use terminal, but that's the hard way. And that's like the ancient way. Like I became a Python scientist using terminal and it's not fun. Although, I mean, it's very solid, but it's not fun. Okay, so for example, let me show you the binder. So you will receive this link to this thing here. If you click here, it will send you to this part here. And then the binder hub is here. This is the way you can find it. You click here and it will start launching something. It will take a time, but it just launches a Jupyter Notebook or a Jupyter Lab interface. Okay. This is for those of you that couldn't install VS Code, for example. All right. While this is just trying to start, whoops, microphone. So, yes. Okay, let's go back. Okay, so you probably start already your terminal. If you have a terminal, let's honor the world tradition of the data science and the computer science community. Just type Python -c, quotes, double quotes, print, parentheses, single quotes, hello world. Okay. All right. I will do it with you. I will start my Visual Studio Code. I will open my desktop. Good. Now here, I can go to View, Terminal. Let's hide this. Let's put this big. And then a little bit more like that. Hello, wake up. Python -c. Print, gosh. Hello, you. Okay, so that's it. You're programmers. You can go now. Anyway, leaving that aside, you can also do this. The second line. Just try import this. So as you can see, it deploys something called the Zen of Python, which is basically its ethos. And if you can explain it to me, I will be very glad because I try to understand, but I'm not Dutch, apparently. And it makes reference to probably something in British culture that I'm not aware of. However, the whole idea is that make things simple. The idea is to make things readable. And the idea is to make it as possible as condensed. That means the lesser the lines, the better. The more comments you put, the better. And the more readable for the other person, the better. Okay? So let's start over here. I can open this. For those that you were here, for example, you have this setup on the Explorer on the right. Now, I also going to cheat because I'm going to use something that is called GitHub Copilot for giving this lecture. If you don't know, GitHub Copilot is a very nice tool that probably you can have. If you're a student, it's free for you. Ask your IT department for credentials, and you will have them. Okay, so here in desktop, for example, I already created something called Python demo. But we can create again something here. Okay, demo 2. And inside that, we can start a new file. Now, here, you can start with something called my notebook. .ipython notebook. And VS Code automatically recognizes the thing. Now, I can close this part here. And this is the way it is laid out here in VS Code. If we succeed in deploying the other one, you will see a layout like this, okay? This is Jupyter Lab. And you can start a notebook just by clicking here. And there you go. Now, in each of these cells, you can run one command, which is nice. This is why it's actually a very nice tool. Print hello. To start debugging or to start prototyping. But, oh, it's complaining that I am not connected to my kernel, which is my Python. Okay, here. There you go. And each cell will just deploy the result that you want or whatever you need.
Why would you use double quotes now?
Double quotes?
Yeah, because before you had this.
Yeah. So one thing about the quotes in Python, stick to one. You can use double quotes, you can use single quotes.
Just check that it works.
Yeah, it works the same. You just have to stick with one for consistency.
So the clause is correct.
Yes. I choose double quotes because the system likes double quotes rather than single quotes in general. But there is the rule is just choose one, stick to it. You can actually do this, the same thing like in the second line. Print hello world. Wait. Single quote here. And there. Oh, Pilot is making me do some things weird. There. It's the same. Okay. So choose one, stick with it, and don't let it go. All right. Now here's the same thing. Here I don't have Copilot on it. So for example, for this, that happens. But you know, it is what it is for this thing. Okay. So coming back to the web pages, we're going to use the data from here. You click in curriculum, it takes you here into the first page, programming with Python. It tells you about the data that you can manipulate here. It's an inflammation data. So there are patients and there is data. Okay, fine. The data format. You know that CSV stands for comma separated value? Yes? Okay, there are other formats that can be better for storing large data. CSV is just the most shared one because it's easy to parse, easy to understand, and usually it's not for super heavy data. Okay. So you have here, you can click the setup. It will tell you how to get your Python notebook up and running. I just show you here in the VS Code that this is very easy. If you don't find it so far, you have to go to extension, and then there you can click Jupyter Notebook. It will appear there. You can just install it, and boom, you will have there all that you need. Also for PyCharm is something like that. So this is pretty handy. Okay. Now, you have this data here. Let's just copy that one. I'm going to copy this thing. Copy link address. And then, for example, the Jupyter Notebook will allow you to do things like calling the bash commands, like ls. Okay. Now, in this case, we can call curl. Curl -o. I could import the iris dataset, but I don't want that. Want something that's called data.zip. That's going to be my name, and then the web page that you want to download. There you go. Already there. We do exclamation ls. You have your data here. In this case, because it's a zip file, unzip data.zip, it inflates everything. And then you have data folder here. Let's go on. So, and see the data folder. And you have your CSV files here. Okay? Yes. With VS Code? Okay. The second command, this one? Exclamation ls? That's curious. You have a layout like this one here, right? Curious. This one here? Okay, this one is the binder hub. So if you go, give me 1 second. KBL. If you go to github.com/caus/bislab/kbl binder serp, you will find this one. Go into GitHub and KAUST bislab repository.
Is there a link to something?
Yeah, it should be over there too, I guess. Because we have the binder project here. Oh, it takes you to the binder documentation. Okay, don't mind. So, GitHub. How can I send this to you right now? Okay. Let me check my email. Oh, wait. Okay.
Chat box.
Not within one night, but
Insent. All right. While I do that, let's give something for you to do. Now, if you reach this part here, you download already the data, right? So you have all of these. Why don't you explore the data like this? Try to open it with any text editor and tell me if you can identify anything. For example, here in the VS Code, you just double click and it will open. Okay. You can do multiple of these. Like in this case, I open everything. Okay. Let's go over that thing. After that, we're going to do something that is like a check. In theory, for all of you that have followed all up to that, up until this point, there is 3 standard libraries that you need to load. For any data science notebook that you're going to start from now on, there is import pandas as PD, import NumPy, as MP, and import matplotlib.pyplot as PLT, just like that. Okay, so now, before I do that, I need to go to the send. Will I have your recipients? Okay. There. Your Alia? Okay. This one? Let's try this one. Can you send me an email too? Can you send me an email? It's not even opening for you on your computer. Mm-hmm. Okay, so I will send you this link. You click in the binder and it should start. All right. So who had problems to loading the three libraries? Everybody has NumPy, pandas, and matplotlib? No. Okay, for those that you already have problems, how do you solve it? Very easy. You can do a pip install. Pip install NumPy or whatever you need, like pandas and matplotlib. If you execute these, it should start actually installing in your environment the libraries. Okay. So in this one, in the VS Code, you just open here in the Explorer. They're going to be downloaded somewhere already in the data folder. You just double click and you can open it here. In the other part, I will have to download it actually with curl. This command here. If you're in here, you will download this and then unzip it. Yeah. Like this. Oh, unzip dataset. Then it opens. In a moment, should actually be here. There you go. It updated, and then there is the data, and then you can double click, and JupyterLab is going to give you this. What's up?
I have already sent it in Discord.
Okay, there is different ways to import it. Is it your desktop? Okay, what are you using? Okay, so are you using VS Code or are you using JupyterLab? Okay, so in this case, JupyterLab must have also all the way here a terminal. In your case is Windows, right? So if you open this, you will have something that is PowerShell, if I recall correctly. And PowerShell still use copy. Then you go to desktop. In my case, I don't have desktop. And then the name of the file, something like that, that's it. And copy here into your now directory. Oh, I wonder if in PowerShell it works with curl. And yeah, anyway, there is this way. Also, if I recall correctly, you can do bring worker directory to know where you are. In our case, this is Jovian in home, but this is Linux. Okay. So here, for example, I can import NumPy, SMP, import pandas, PD, and import that. Now, this is some Jupyter magic. When you don't remember what are you actually typing, you can just put a couple of the letters that you are trying to remember, double tap, and you will have a menu that pop up. And it will have your different options to go over this. Could be math, it could be matplotlib. And then you have all these other options inside matplotlib. Okay. So far, everybody has problems with it. I know. This happens every time.
So I think that's, I didn't hear how do you get to evaluate those cells?
Yeah. So for this one, specifically for this one, you press Shift Enter and it executes. Yeah, that's one. You can go to run. Select cells. And for this one, it's even easier. Just push play. And then it just go and do its magic. Okay, for example, I just commented this, good. Now, this is actually good. Now that we have that data, we can move on. You can push home again if you want. And then let's go to Python fundamentals. Now, anybody has experience in programming, right? Like, who doesn't have any experience at all in programming? A couple of you, 2, 3. Okay, that's fine. People that is next to them, please help them. But okay, so very quickly, there are things that are called variables and there are types of variables. Variables because, well, you already passed algebra, so it changes value, right? Now, in Python, I would say that there are four main data types. Well, four main variable types. The strings, like hello. Then you have integer numbers, then floating point numbers, like these two, and booleans. Now, this is boolean. Boolean, thank you. This is called float. And these are called int inside Python. And this one for short, str. Okay, for those of you that don't know anything about computing, this is basically canon for all the other computing programming language. They have these type of variables always. Well, almost always. They have also special variables that you can search around to. Okay. Now, you will find in the web also this explanation, even more carefully, because you can use Python as a calculator, right? You can do 3 plus 5 and you will get 8, and then multiply it by 4. You can do it in one line. Now, what starts making Python very flexible is the following. You can declare, let's put this aside. Now, in languages like C or more rigid languages, you have to do like variable 1 equals 1, variable 2, and then you have to tell the type like, oh, I want this to be a float, and you have to put 0 points like this. However, this is valid in Python. However, in Python, you can do v1, comma, v2 equals, I don't know, duck, comma, and then 0, 1. And this is valid. That's the idea of Python. Put everything in one line so people can read it. Easy, simple. And then you can just invert them. You can do something like now. V2 equals V1 dots 2, that's V1. Now, I just inverted the values. This in other languages is a pain in the ass because you have to do like 10 lines to do this. This is the part of flexible Python. Okay, that explained. We just move on into the following. You already see printing, right? How do you print your own name? The first exercise for you is print a variable, whatever you choose. Try to print it. Yeah, just try to print a variable. You will find, obviously, in this big string, the answer.
Yes.
Like, for example, you can print a variable like this. Now, one of the things that Python can do is also formatting. You can print v2, v1, and it will just output 1 and 2. However, you can go and put the formatting inside, like this. v1, v2, and then 1 pound per. Oh gosh, not pound.
What is the F?
The F is for formatting. Okay. So if you put F and then double quotes or single quotes and then how is called this thingy?
Curly braces.
Curly braces, thank you. Then you can just input there the variable you want. Okay, so for the next, let's say 3 or 4 minutes, why don't you try to sum up two variables and print the result? Okay, very easy to do. Just try to print it. Any two numbers, just sum it up and yeah, two numbers, sum them up and print the value and do the sentence. I am summing up A plus B equals C. And A and B are the values of the variables and C is the result.
So you want to use variables, you will assign them to variables?
Yes, assign variable
And then print. Okay.
and then print, yeah. Okay. So, question for you. Did you get it up? Is it? Okay, excellent. All the way to the back. Were you able to deploy Jupyter? Okay. I know you can. Is actually here. If you go here in programming Python, is the first page. You go to setup and you have the links here in obtain materials. So it's here. Down, 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 setup. And here you have code and data. Okay. What I did was to copy the link and then use this here. Curl is a bash command, output the name that you want to give, and then you paste the complete link to the data. Okay. Now it was something like B1 equals 1, B2 equals 2. And then print. B1 plus. Could be like that. No. Could be like that. Yes. Okay. Python could be very, very easy if you go into the nitty-grains of it. You can do something like this. You can do something like B plus 2. But don't forget the formatting here. Yes. What is what? Why there is print, then the F, double quotes, and the curly braces?
Yeah, I'm asking about the F.
The F stands for formatting, because the F can be also in the form of going all the way outside, dot format, and then here you can put B1, B2, but then you cannot do the operations here. You can leave these curly squares there, and it just passes the value of that into the squares, into the curly squares. The F is just a abridged way to do it. This one is basically the same as this. Easy Copilot. . Yeah, sure, we can produce that, but no, that was not the point. So one thing about Copilot is like people say it's artificial intelligence, but it goes really, really quick into not be that intelligent. Okay, so these two lines are basically the same. That's okay. You can go into these details even further because print has a plethora of things that you can use. If it has here, oh, go down, go down, go down. Print. Come on, print, wake up. Okay, a little bit shy. And anyway, print has a lot of menus that you can use. Let's see if here I can deploy them. Not in Arabic for sure. Yes, here it is. So in my computer, I have something that is called kite, that it will deploy the documentation of whatever function I'm trying to use. In this case, if I pass the cursor here, it opens that, and I can see, okay, print has more things like a separator or even an end and stuff like that. It's a very complicated function because it's very broadly used. I mean, you have to print whatever sometimes in your screen, right? Okay. Now, brace yourself because we're going to do like a quantum job. It's going to be like a really, really, really stressful jump between this part and the data analysis we're going to try to do. So if we go back to this part here, the lesson will start to tell you how to use NumPy to start analyzing the data you just downloaded. So from printing, you're basically going to import already the libraries that you need to start doing data analysis, which is, in my opinion, very, very, very long jump, but this is how they design the lecture. Anyway, so what I want you to do is to follow this part here. So you can get all the way to this part here to slicing. Why? Because the first part will tell you how to read data from what you have done. So your first task right now is try to read the data, one of the things that you downloaded in using NumPy. Okay. It'll be like this. And then you will see what happens. Yeah, go into the web page, and then you can find this part here. Just follow this, the first 3 steps.
Now we need to use NP instead of NumPy.
Ah, okay. So you import NumPy here, like import NumPy as NP. So you can basically abbreviate the name of NumPy as np.load.txt, and it's the same. Python gives you this kind of flexibility of just naming the thing into another thing. It could be AC or whatever. Now, Copilot is already giving me some answer. Yes. So in the on the email that you receive, there is a link One more. What's going on? This one. Okay, so I sent you this link. Okay. Then go and push curriculum. And it will deploy this one. Okay. All right. So were you able to load one file?
Yes.
Yes. So it looks like this, right? Now that brings me to one thing. Also, let's go. Copilot, give me create one list. Yes.
In this coding, we're loading the text. For the file name something. I don't think we want to provide the direction of this file before uploading it to the file thing.
Yeah, because here is this file is living inside data folder. So, here one, you can just explore it here. For example, I have data here next to this thing here. This is where I downloaded data.zip and deployed. Yes. Okay. For those of you that are more advanced, you can do something like, where are you going? Get the current. Thank you. Pilot. So there is a module called OS. And OS will get you this, and you can set it to a variable called path. There are different ways you can set the path, and actually, if you're interested, you can go to the next lesson. The next lesson has actually how to load everything from the directory you're pointing to. In this case, path is my path, where I am.
And so can I do set?
You can set the path for sure. You can, I just set it, I just put it into a variable, for example.
Yeah.
So from there, I can just read it once and again and again and again. If you want to really set it into the OS, you have to go to export, but that's a shell variable. Do you know shell?
No.
Okay. That's the global controller of this. Yeah, so that's the thinking. Okay. So create one list with range, please. Okay, thank you, Copilot. My list equals range from 1 to 20. So in this case, not very often I can see this. Great. Better. So in this case, for example, my list is something like this. So this notation in another kind of languages is called a numeric array. Now, thank you. Create it. Now, from here, what I did was transform to something that's called array. My array using something. Now, this notation basically is the same, right? You have 1 to 10 between square brackets. One has the word array in front, the other one doesn't. Now, what do you think will happen if I do my array times 2? That could be. And if I do my list times 2? In theory, we think like I'm going to multiply everything by 2, right? Each of the elements. See? Now, for arrays, that's correct. But for list, you duplicate the list. So these type of things can change. Yeah. List literally is like a list that you do for your groceries, and you just keep adding and adding and adding and adding. You can actually modify it, but it's not for mathematics. Okay, this is the basic difference between array and list. Array will actually keep the value, and then it will perform mathematics on the value, while list is a different thing. You can use it like for holding a place. Okay. That said, we have already loaded that thing. Give me a break. Not here, and then, come on. Okay. NumPy inf1. Okay, so I assign this load here. Perfect. Now, in the next exercise, import pandas. Pandas SPD. And let's do the same, but we're going to call this variable data frame. And we are going to say header none. Okay. Type this one. Just like that. You're going to import pandas as PD. Then df for data frame. For those of you that use R, data frames are very easy to remember, right? So this is the way you input data frames using pandas. Then you give the position of the file you want to read, and then do header none. Header none, because if you see this file here, it's all numbers and no headers. So we don't have the name of the columns. Right? Yeah. Something like this. You could copy it, or you can just write it. In theory, you can double tap and it should appear in your menu. It shouldn't give you an error. You are using one single quotes like this. No, like this one. You cannot mix them though. Yeah.
I'm getting error, and I think it's because I didn't set the direction of this file.
Okay.
It's properly directed file, and that, like, my file is stored in
Okay. So one of the ways is actually going in the Explorer. Then you have data here. And here in this menu here, there is copy path. or copy relative path. So you can go copy path. Let's close this because it doesn't see. And it will give you the complete path where your file is located. Then my file. Instead of putting the whole thing inside, you can exchange that for my file. Okay. Now you have both things, right? You see this array. We can perform different mathematical computations over this array, but you can see also the difference with pandas data frame. So there's a glaring difference, right? Between what NumPy does and what pandas does. Now, pandas and NumPy are basically brothers because pandas is leveraging NumPy. Now, before we take a break, there is something that I want you to do. I want you to perform this operation here. I want you to get these things done, okay? Because you already loaded the inflammation 1 CSV, you can now visualize what's going on, okay? That's in the visualization tabular data of the web pages. Okay, let's do that. And once you get it, let's just have a break for a couple of minutes. So 1, 2. Yes. Now, I want you to replicate this one. Okay. Whenever you have, you done it? Okay. Done? Good. Okay. Let's take a break. Okay. Yes. Yes.
I don't know how is it possible that I can see with the other command, but not with this one. I don't know.
So you're missing one file with the same directory. So you found your file before and now it's lost. Mm-hmm. Okay. So what are you using? The notebook. So you're using this guy. Okay. So here, if you're here, you can do an ls question mark. It's not connecting. Oh no, I hope it's still alive. Are you here? Ah, yes. Okay. So you can open a terminal all the way here. Then you do an ls. And data should be there. Mm-hmm. So enter the data folder like this, cd data, and then print working directory, pwd. Yes, because you just push plus all the way to the bottom. There's a terminal icon. You don't have it? Do you have it here? Huh. Okay, that's curious. Maybe there are so many.
Because mine is only like it says insert cell below, so I don't have the option to.
Okay, yes, it's different then. Okay. So in here, I think you can also do the following. You can go here and copy path. Okay, go. If you can see your data from here, you cannot see it. Oh, it looks. You have it like this. There is no pan. Ah, you're using a notebook itself.
Yeah.
Yeah. But it's like you're not in Jupyter Lab. You're in Jupyter Notebook by itself. Yes, Jupyter Notebook started like that. I mean, the whole Jupyter project started like that, like you're using it right now. So you have to come closer because the same button exists, but it's not in the same place.
Okay, come to the.
I don't remember because that one is an old way to do it.
Okay.
But there is a way to do it. There is a menu for that. I think it's in the right corner, right upper corner. There is some drop-down menu that says new, and you should have like some options there, like terminal or something.
Where?
Right upper corner.
In the same place.
Yes.
There's
Okay.
Yeah. But the thing is like, because people get lots of you, they do their thing together. One look.
But why did I get this one? Because I this is how I also
Yeah, you can do that. Yeah. Yeah. When you are only. Inside here. We should not should be the last, not do the song. I mean, we will have that layer.
I'm using actually the that, and then I just uploaded the file information one. Now in here in this search, should I space this line with the word uploaded?
No, I don't think so, because we have to upload it.
So what's the directive regarding this?
Open a new set. No explanation with this. Exclamation. LS. Yes.
Just visualize these. I mean, yes. So they don't think as a data set, they keep it.
Yeah, that's it. I mean, you can, if you need to visualize it in another ways.
I guess it did, yeah.
Okay.
So we run that.
Yeah. This is the kind of the.
But when we see the
Here, for example, we want your virus. So, you mean like where we use the in vaccine?
like what we made. It was, anyway, yeah, I don't know what I could use some can't see it somewhere. So like we use like data, yeah.
Right. You mean like
Yeah.
okay. That part would be yes.
So do you have this goal? It didn't work.
Yeah, no, it should be here. That's it. Because all they provide is the US interview.
Okay, so it's on the and you can't visualize it.
Yeah. So you use this delivery there. They probably
Okay, just quick look at the chat. All right, let's resume. So you already went and performed a very good job doing this visualization, right? Now, one of the things that you can do before we continue is actually download cheat sheets. Pandas has a cheat sheet that is actually an official one, and then it looks like this. So it's a good reference for you to work later. As a matter of fact, if you are using VS Code, you can double click in that thing. I think I'm downloaded here somewhere. For example, this is another cheat sheet, but it's still valid. You can download it and put it here next to you. Let's download that one. So in the desktop. Okay. View terminal and move. Let's cheat sheet to demo Python, demo 2 there. Now I should have it here. I have it there. No, I mean, because this is basically connected, this is my way to do it, but you can just drag and push from whatever you want. This is my way, sorry. It's the way of the ancients, actually. So this guy can be here. Okay. Go there, where are we? Something went wrong with my pandas cheat sheet. It should be here. I mean, I just put it here. But it didn't download properly for some reason. Okay. The point is that you're not alone. There is a plethora of different instructions that you can take from here to use it to analyze the data frame that you already put it in Python, in pandas. Yes. Okay, you just Google it. The first hit is this one. pandas.pydata.org will take you to these guys. And then you can fail like me trying to download it. Should be there. Maybe if I do this. I am thinking that one. Yes, probably I'm not doing it. There you go. Okay. Maybe it was too big at the beginning. Then I can put it here. There you go. So you can do these kind of things also with the Jupyter Lab. You can put like different panels, where to put your terminal, where you put your code, where you put everything. Okay. It's not a static thing. You can just deploy whatever you want in different parts. Just like this. Now, I will just close this one. That's okay. Okay, so you succeed to do basically a heat map of all these numerical data here. Now, what happens if you want just to do one column? You can actually slice the data like this with NumPy. This is basically give me the first line, give me the first row, and everything else. And then you can see that this patient, for some reason, it has a temperature to go all the way to 17.5 during 40 days. This should match what you're seeing in your heat map. If you put this apart, you will see the series of numbers, right? On the other way, if you want like the other side, this is the first column. Like this, here is the columns, these ones are the rows. That is also valid for pandas. You can do the same thing with pandas. You can just slice things. And you can actually ask for subsets of things. Like, for example, I want from day 5, I want 4 patients the first 10 days. And then you have this matrix here. And you can plot it with your function that you just used, for example. Just these for patients on the first 10 days. Now,
5 patients in 11 days.
5, yeah. Why not? Maybe it was a month, something like that.
That's what I mean.
Yeah. So let's see if this applies here. So you can apply things on top of this using NumPy. NumPy has a lot of different functions. For for example, numpy.min, and then you apply it into a subset of these things. You can do the same with pandas. Now, what I want you to do is to try to find the same thing here, the mean, how you get the mean, but from the cheat sheet. So once you have the cheat sheet, look for it. Where is it? It's blatantly there. You will find it. Okay. So as you can see here, you have different operations, right? It doesn't directly say what is going on, but you can see that these helps you to summarize data, which are the same as NumPy operations, but for the data frame. The way to invoke it is different the way to invoke them is different to NumPy, because you just call them like sum or average, mean. And it goes and does the mean for all the 39 columns that you have. Or in this case, you can call the axis. That's it. So you can go over rows or over columns using axis. Axis 0 is for rows, 1 is for columns. And this is exactly the same thing that you would do with NumPy. Why? Because pandas is built on top of NumPy. As a matter of fact, you can go even further, because with pandas, to plot something, you just need to call plot. And that's it. You can start analyzing your data. For example, this is the the mean value for the temperatures of 40 different people, right? Or 40 different days. So it's very easy to find, it's very easy to actually manipulate. For example, here you can put kind equals bar, and it just transforms into a bar plot. Okay?
Instead of putting dot, like composition.
Yes. So putting dot and dot and dot, this is something that is not very easy to adapt. Yes, because it's backwards, but it's like you have a function here and then a function there, and it's like you are plotting this that is behind me and then behind and then and so on and so forth. Some functions take arguments, some other doesn't, but most of the pandas ones take the arguments. NumPy also. Now, what I want you to do is actually now try to go and select just I don't know, again, 4 different people from using pandas. It's in the cheat sheet. And I'm going to tell you, it's using something called lock. So search for the lock thing, the lock function in the cheat sheet, and try to just subtract 4 patients or 4 rows, and let's say, I don't know, 15 columns. Okay. Okay, you got it in the cheat sheet. Is what it says subsets, rows and columns. The answer is here, basically. Yes.
Change the name.
The name too, like you mean like all the data or just the file itself?
Just fine.
Okay. That's a new one. I would do it with Bash actually to change the names. Because usually you don't change the name of the input. Still, you can do it. For example, I would do a copy, as a matter of fact. You can, in Python, you can leverage also the commands from the system. So you can do something like import OS. And with OS, you have OS dot. Let's ask, you know what? Let's ask Google GitHub Copilot what it thinks. Like change the name of the input file. That's our input file. Fine. And then it does nothing. You see, artificial intelligence is not that intelligent. But anyway, I would import OS and then os.system. And with this, you can invoke whatever you need to move. For example, you can do an ls, or you can do a move data to data, I don't know. Let's call it my data. Instead of moving, just copying because I don't want to eliminate it. You don't like that. Would be system then. There. It was system, not sys. So with OS system, it gives you access to the shell or to whatever you're running, PowerShell maybe, and then you just input whatever you need there. In Jupyter notebooks, it's even easier because you just put a exclamation point, the same thing, exclamation mark, and it just runs. So the Jupyter notebook is very, very flexible to just going around doing stuff. This is Jupyter magic. There are other things like other commands like time. This command here, the double ampersand, it will time how much time do you spend in that cell just exploring this print, for example. It could be a big chunk of a different function, but this is something that only Jupyter gives you in this sense. Okay, were you successful in just subsetting a number of rows and a number of columns? Sort of.
What's the name of the data set we want to subset?
The df. Yeah, just put just df dot, if I recall correctly, is ilog. Yeah, as long as if you define the function, if you define the variable data equals pd read whatever, just data dot, it will have the functions attached. Just like this, like 4 rows, 10 columns. And with that, we should be able to plot again. Okay. I want a bar. Kind equals bar. So in this case, I have different patients with their different temperatures. There is something strange about this 10-day, but still, the first days, they don't have that much problem. Anyway, this is a way of how you start just doing analysis. You can do it over the whole data set, but the bigger the data set, the more problems you have. Okay. I hope you're prepared for the next part. So how do you import all the different data sets that we have here? Because remember, we download this thing and we have data and we have a bunch of different inflammations point files. So usually, as a good data scientist, you probably run, I don't know, thousands of simulations. You have thousands of points, hundreds. Maybe you have 5, but still you have like, I don't know, different files from different experiments, different situations. Now, here in the material, there is, if I recall correctly, it's in the next one. Yes. Here, all the way to this part here. No. Not this one, not this one. Wait. Anyway, I'll just show you. So we have several of these files that are like in this file, in this kind of format, right? So there is a library called glob that you can, let's put this away again. Import glob. So this guy here is going to give you access basically to the global environment that you have already working. Now, get all the files. I know that GitHub Copilot can do this from the data directory. At least he knows what I'm going to do. Import glob. There. It's very simple. If you want to import all the different files there, you can put them here. And glob.glob, whatever is your directory where your data is living, which I am very proud that you figure out where your data is, it will return a list of those files that are there in this data directory. In fact, you can go even further and say glob.glob inflammation. Come here. What glob doesn't like sometimes is wildcards like this. Remember to stick to one. Glob.glob. Before that, oh, come on. Flash plus, yes. Really? Using to. Let's see. Wow. Okay. My files. So there, we have imported only the list of inflammation files that we want. It's this simple, just import glob, call it like that. There is another more complicated way that I used to do, which is importing OS. Yeah, this line here. That's all you need.
So it's auto-completion thing is only in Jupyter Notebook.
Yes, the auto-completion thing is in Jupyter Notebook. The stupid auto-completion is because GitHub Copilot. GitHub Copilot. When I try to put some kind of thing like this, like comment, and it appears in gray, that's not the Jupyter Notebook, that's GitHub Copilot. It's auto-completing for me. Like, for example, get the current directory and it auto-completes the thing, but it's not actually me. Okay. Okay.
Why don't you have, so you're using test4, right? So
yeah.
Install to get all this automation.
You go here, extensions, and put Copilot. There, this guy. Now, because you're in a university, in theory, you have access to it. Okay, you just have to really, really, really know how to control it, because by itself, it does nothing. But yeah, it's there. And this is only for VS Code, which is, it only works with this guy, with VS Code. Okay. OS.list year. It was my favorite to go when I was a child. Data. Okay. Like this. Maybe it's here in data. There. So OS list here also make a list of the directory you are. You just take everything. Now, for those of you that are wondering, yes, you can filter these kind of things with conditionals. You can do something like a for loop for element for E in this thing points print E. This is the way you do for loops here in Python, and it annoys a lot of people because it doesn't have the normal notation. And you can start filtering stuff here. Oh. There. Let's put C1. You can wrangle the data with so many ways in Python that it becomes confusing. Now, what I want you to get only is like, you can do so much better using just a simple line rather to trying to complete things in 2-3 lines. Once you have these, for example, my files list, you don't need to do this. You can just put it into a data frame. Data frame equals the dot read CSV. My list. Instead of that thingy, my list. What happened? Is this? It's my files, not my list. There. Neither. Oh. Why? Usually, it's expecting just some kind of variable here. Which it works for the first thing, which is strange. Okay. This is an unforeseen thing, but you know, with live coding, we usually do this. Anyway, what we can do is the following: for m in my files. You can read each of one of them like this. And there you go. You can print, you can get an average, and then you can plot it. All in the same line. Now, like I said, you're going to walk away from here with more questions than answers, because the way you manipulate pandas could be very effective and could lead you very easily to manipulate all your data into GPUs, depending on the different library that you have. Okay, last but not least. Oh.
Everything we did so far, they've been done with R.
Yes, exactly the same. It's the equivalent of R. So the idea here is like if you are a hard Python, you can enter R by knowing pandas, or if you come from the R universe, you can try to enter Python using pandas, because they are similar and their functions are on the same way. However, you can have different things of plotting things. For example, in R, you have ggplot, which is amazing. I love ggplot, but I left it when I understood that there are other things like plotly, which can give you very nice layouts of different plots. Or you can do something like Seaborn, which is also very powerful for visualization, and it plays really well along pandas. You just need a pandas data frame, and it plots something that is worth of a publication, quality-wise. So, if I recall correctly, now you can do stuff like that. Yes, you can play along with R and Python. So the thing is, there is a silly fight, right? Who is the best programming language for data science? And the Pythonista says like, it's Python. The R heads only is R, but it's a universe. It doesn't matter. The world doesn't run in Python. The world runs in JavaScript, right? But Python is there because there's AI, there's the flexibility. Is it the fastest? No, C is more fast. Is it better? Not really, but it's very flexible. R is magnificent for statistics, but then it just gets stuck in the statistics and doesn't have the amount of people working in Python, right? So all of these can be, yes, done in R. That's the point of this workshop, actually, because like I said, you need like 3 months to be powerful in Python, which is a very short time. But if you follow this material here, this material will give you all the exercise you need to be really dangerous with Python for analysis. Okay, I just tried to give you the setup because it's as far as I can go in 2 hours. And then you can play around with it later. And the more you advance, the more you will get into AI and so on and so forth. And for that, you can always come to my office or drop an email. All right, but this is as far as we have for today. So I hope you get, well, confused, but then you know what to look for the next time. Okay? All right, thank you very much for coming. Here.